Machines slice soft wood into thin splints, steam-powered cutting equipment, producing thousands of matchstick bodies with the precise dimensions necessary for reliable ignition and safe handling. Workers dip frames holding hundreds of splints into chemical compositions containing phosphorus and other reactive substances, coating the tips with materials that will ignite through friction when struck against prepared surfaces. The dipped matchsticks undergo careful drying in controlled conditions, transforming wet chemical coatings into stable heads that remain inert until deliberate friction initiates the chemical reaction producing flame. Finished matches are counted and packed into small boxes displaying brand information and striking surfaces. The complete production process, creating the convenient fire-starting implements that revolutionize domestic and industrial ignition. This is just part of the systematic process transforming wood and chemicals into matches inside this 1850s steam-powered factory. Before we continue with the complete process, if you could leave a like and subscribe to the channel, it would really help this project continue bringing historical industrial content. Thank you for your attention. Now back to the video. Softwoods arrive at the match factory in logs, species such as pine, poplar or aspen, selected for their straight grain and ease of cutting into the thin splints forming matchstick bodies. These woods must split cleanly and possess sufficient strength to withstand handling, without breaking while remaining soft enough for efficient machine cutting into the delicate dimensions required for match production. Workers unload timber deliveries, organizing logs by species and quality to enable systematic processing through the cutting operations that will transform solid wood into thousands of individual matchstick splints. The wood selection proves critical for production efficiency and match quality, as harder woods damage cutting equipment, while woods with irregular grain produce splints prone to breaking during subsequent handling and chemical treatment operations. The wood undergoes initial processing to remove bark and cut logs into lengths matching the cutting machinery's capacity. Workers feed prepared wood sections into steam-powered cutting equipment that slices material into thin sheets of precise thickness, determining final matchstick dimensions. These cutting machines represent significant mechanical achievements, maintaining the accuracy necessary to produce uniform splints, despite processing substantial wood volumes throughout operating shifts. The cut wood sheets display the characteristic grain patterns and natural variations of the source timber, ready for the splint cutting operations that will separate individual matchsticks from the continuous sheets. Splint cutting machines transform the thin wood sheets into individual matchsticks. Precision cutting equipment dividing material into thousands of slender pieces, displaying the familiar matchstick form. These machines employ rotating knives or guillotine mechanisms that sever wood with remarkable speed and accuracy, producing splints of consistent width and length, essential for reliable chemical coating and ignition performance. Steam power drives the cutting machinery through heavy gearing and belt systems, sustaining the rapid mechanical action necessary for processing the enormous splint quantities required for industrial match production. The cutting operation generates substantial wood waste as sawdust and edge trimmings, materials typically collected for use as fuel in the factory's steam boilers rather than being discarded as valueless refuse. The cut splints undergo drying to remove moisture that would interfere with chemical coating adhesion and prevent proper head formation during the dipping process. Workers spread splints in drying rooms, where controlled air circulation and moderate temperatures reduce moisture content without warping or cracking the delicate wood pieces. The drying duration varies depending on initial wood moisture and desired final levels, with workers monitoring progress and relocating splints through different drying zones as moisture reduction proceeds. Properly dried splints display the dimensional stability and surface characteristics necessary for accepting chemical coatings evenly during the head-forming operations that create the reactive tips enabling match ignition. If you could leave a like and subscribe, it would help keep this channel active with quality historical content. Thank you for your attention. Now, continuing with the process. The chemical head composition represents the critical component enabling match ignition, with carefully formulated mixtures containing oxidizing agents, fuels, and binders that react violently when subjected to the heat generated by friction during striking. The 1850s match industry employs white phosphorus as a primary reactive ingredient, despite this substance's extreme toxicity and tendency to cause severe health problems among factory workers through chronic exposure. The phosphorus combines with oxidizers such as potassium chlorate and fuels including sulfur, creating compositions that ignite readily but pose significant manufacturing hazards, requiring careful handling and ventilation to minimize worker exposure to dangerous fumes and materials. Workers prepare the head composition by mixing chemical ingredients with water and binding agents, creating thick pastes that will adhere to matchstick tips during dipping operations. The mixing process requires careful attention to proportions, as excessive oxidizer creates matches that ignite too easily and burn too rapidly, while insufficient reactive materials produce matches failing to ignite reliably when struck. The prepared compositions are transferred to dipping vats, where they will coat matchstick splints, the thick consistency enabling proper coating formation while preventing excessive dripping that would waste expensive chemicals and create irregular head shapes affecting ignition reliability. The dipping operation transforms plain wood splints into functional matches, with workers immersing frames holding hundreds of splints into the chemical composition vats. These frames position splints vertically with their tips downward, enabling uniform coating as the chemical paste adheres to the wood during immersion and withdrawal from the vat. The dipping depth determines head length, with workers controlling immersion to create consistent coating, extending appropriate distances from splint tips. Each frame may hold several hundred splints, enabling efficient production of large match quantities through single dipping operations that coat numerous pieces simultaneously. The dipped matchsticks require careful drying before packaging, as wet chemical heads remain vulnerable to damage and fail to ignite properly, until the coating achieves proper consistency through moisture removal and chemical stabilization. Workers transfer dipping frames to drying areas where matchsticks remain suspended, while air circulation and moderate temperatures remove moisture from the chemical coatings. The drying process proceeds gradually to prevent cracking or separation of the head material from wood splints, conditions that would create defective matches unable to ignite or prone to head detachment during handling and use. The drying duration varies with head composition and ambient conditions, with workers monitoring progress through visual assessment and occasional testing that confirms adequate coating stability for safe handling and reliable ignition performance. Some match production includes secondary dipping operations, applying paraffin wax coatings over the dried chemical heads, creating protective layers that improve moisture resistance and enable smoother ignition by providing additional fuel that catches fire readily from the initial chemical reaction. This wax dipping follows the same systematic process as chemical head application, with frames immersed briefly in molten paraffin that coats the dried heads and portions of the adjacent wood splints. The wax coating solidifies rapidly as matches are withdrawn from the paraffin vat, creating smooth surfaces that enhance match appearance while providing functional benefits, improving ignition reliability and storage stability. The dried matches are removed from dipping frames, workers carefully extracting the delicate splints without damaging the chemical heads that have become firm, but remain somewhat fragile until fully cured through extended storage. This removal process requires skilled handling, as rough treatment breaks matchsticks or dislodges heads, creating waste and reducing production efficiency. The removed matches accumulate in containers for transfer to counting and boxing operations, the loose matches displaying their characteristic appearance with colored chemical heads contrasting against natural wood bodies. Counting and boxing operations package matches into the small containers, serving retail distribution, with workers arranging precise quantities into boxes, displaying brand information and striking surfaces, enabling match ignition. The counting process may employ simple manual methods or mechanical counters that improve accuracy while maintaining production efficiency. Workers fill boxes systematically, positioning matches with heads oriented consistently to enable compact packing while preventing damage from matches rubbing against each other during handling and transportation. The filled boxes are closed and labeled, creating the familiar commercial packages that will reach consumers through retail distribution networks. The matchboxes themselves represent important manufacturing components, with small cardboard or wooden containers produced specifically for match packaging and incorporating friction surfaces enabling match ignition through striking. These boxes display printed brand information, usage instructions, and decorative elements that distinguish various manufacturers' products in competitive markets. The striking surfaces contain abrasive materials and sometimes additional chemicals that generate heat through friction, initiating the combustion of match heads when splints are drawn rapidly across these prepared surfaces. The production of matchboxes represents a separate manufacturing operation, often conducted within the same facilities producing the matches themselves, enabling coordinated packaging of components into complete commercial products. Quality control examines matches throughout production, checking splint uniformity, head formation quality, and ignition reliability that determine product value and safety. Workers test samples from production batches, striking matches to verify proper ignition and observing burning characteristics that should display steady flames without excessive sparking, smoking, or premature extinguishment. Any batches failing quality standards are separated for reprocessing or disposal, preventing defective matches from reaching markets where poor performance would damage manufacturer reputation and create safety hazards from unreliable ignition or dangerous burning characteristics. The match industry serves essential fire-starting needs across all economic classes and applications, from household cooking and lighting to industrial operations requiring convenient ignition sources. The 1850s represent a period of dramatic match industry growth, as improved production methods and falling prices make matches increasingly accessible, displacing traditional fire-starting methods, including flint and steel, tinder boxes, and other approaches requiring more time and skill than the simple friction ignition offered by matches. The convenience of match ignition transforms daily life, enabling quick fire starting for cooking, heating, and lighting purposes that previously consumed significant time and effort. The health hazards associated with white phosphorus match production become increasingly recognized during this period, with workers suffering from phosphorus poisoning causing severe bone deterioration, particularly affecting the jaw in the devastating condition known as phossy jaw. These health problems will eventually drive regulatory action and industry transitions towards safer red phosphorus and other match compositions, eliminating the worst occupational hazards, though the 1850s factories continue employing white phosphorus despite growing awareness of its dangers to workers. Inside steam-powered match factories like this, mechanical processing and chemical coating transform wood into convenient ignition products through operations combining woodworking precision with hazardous chemical handling. The machinery continues operating, prepared to receive new wood shipments and chemical supplies, for repeating the cutting, dipping, and packaging cycles, creating the matches that simplified fire starting throughout society. Steam power drives the cutting and processing equipment while enabling the sustained production necessary for supplying growing markets, though the chemical handling operations remain largely manual due to the dangerous nature of materials requiring careful worker oversight. The transformation witnessed here represents the industrialization of a crucial everyday technology, making convenient fire starting widely accessible while creating significant health costs for workers exposed to toxic materials during manufacturing operations. Did you know that match factory workers in the 1850s often suffered from phossy jaw, a devastating condition caused by white phosphorus exposure that literally destroyed jawbones? If you enjoyed learning about industrial match production from the 1850s, please subscribe to the channel, leave a like and comment about what surprised you most. Your support helps us continue bringing historical industrial content. Thank you for watching. See you in the next video.